Thank you everyone to be here. My name is Erwan. I am the CEO and founder of Vytruve, but I am also CPO. And today I want to talk to you about digital transfer, manufacturing for definitive socket, and many other things. So I'm really happy to be here. We have launched a video last week about this subject. I hope you liked it. So now we are going to give explanation. Don't hesitate to ask question or to put question in the chat. It's in live, so we can exchange. I can stop, and you can doing this a little bit more great. So. We are going today to talk about digital transfer. It's the first patent we had since 1 year, and we have another patent. It's the positive and installation guide. We are going to see it in few minutes, and also manufacturing. And at the end, we are going to talk a little bit, and we are going to answer a question, and I'm going to answer a question. So when we talk about transfer, what are we talking about? So what is a transfer? A transfer is a copy of a shape and alignment. It's what the CPO do when he do his job. So it's important to have the good shape, the good alignment, and a transfer. The goal is to copy it. It's to copy it to do many things. First, to transfer from a check socket to a definitive socket, or to a check socket to another check socket because you want to reduce one or two socks and you don't want to redo everything. Also, sometimes when the socket is very great and you want to modify a little bit, it's possible to transfer it from a definitive socket to a check socket. And after, when the socket is very good and you want to change nothing or just a really small thing, it's possible to transfer definitive socket to another definitive socket. And the subject of transfer is the same in rehabilitation center or in private company. The CPOs need some time to transfer, and it's very important for the comfort of the patient. And transfer is possible for TTTF and other devices. So what is the problematic of the transfer? So here I have the manual transfer. So I did by myself, I think 1,500 transfer. So I know this very well, and I think many of you already know this. It's a great tool when you use plaster because you can do a great job, but things are changing, and this transfer have many problems. First, if you want to transfer with these things, it's necessary to have the equipment. And it's also necessary to have a workshop, because when you are in the rehabilitation center or patient home, you don't have equipment and you don't have your workshop. So first problem, to have the equipment and also to have the knowledge. It's complicated to do a manual transfer because you can do many mistakes during all the process. And it's also necessary to have time, because if you want to do a transfer, it's 1.5 hours, 2 hours to do it if everything goes well, and you need to be focused on it. To use this transfer, it's also necessary to use plaster, and the problem of plaster in our industry, it's the humidity. Because if you want to do silicone injection or a carbon injection, it's necessary to to laminate on it, and humidity, it's really a problem. It's also, during manual transfer, a risk of important error, because you have to screw, you have to cut the socket, so many things can happen, and for technician, positive are very heavy. Technician do the manufacturing every day, and every day they have to carry very easy positive, and it's not very nice for them. It's not very easy. Also, it's also complicated when the shape of the socket it's not easy with many shape, because you have to remove it, and sometimes you broke the positive or you change the alignment, and so on. And the most important thing, when you do a manual transfer, you keep the socket of your patient. So when you do the definitive socket, your patient don't have the socket, and the limb can change. You have to manage the agenda at the workshop. So there are many problems with a manual transfer, and that's why we have worked on a digital solution. It's what we are going to see. So it's great to talk to you, but the best is to do a demo of what happened with this digital transfer. So we are going to transfer this socket. So it's easy with a TF because the socket is big. So it's not easy for TT. So that's why I will transfer a TT socket. So I will follow all the process in Vytruve. So we are going to see it. I will create the patient directly in Vytruve, and we are going to follow the checklist, perform the scan, and after order everything. So I'm going to share my screen to show you this. So I will connect to Vytruve. When I'm here, I will create a patient. Patients. We are going to put day. I am the CPO. The localization is okay. TT. It's right side, and I will create a device. Okay, here is the patient information. It's not necessary for digitalization. Silicone, sleeve. I will select a foot, and I will click next. Now my patient folder is created. I will click start a scan, and here on socket for digitalization. I click, and I have the checklist who will tell me all the material to prepare. So here I can follow everything. So my material, it's okay. My equipment is okay. I will connect to the computer, to the power. It's okay. I connect the scanners. I will calibrate the scan. I already did it. If I need information, everything is here. I will continue. So no need to remove valve, or so it's not necessary to remove valve or other things. So I will do this just to screw in order to don't lose my alignment here. And I will position this on the V pyramid of my V transfer. So like this. So just before this is the new transfer. So it's a V transfer. You can see that it's very light. I can bring it where I want. I can go to the patient. I can go to the rehab center, and we are going to scan inside and outside the socket. So I will position my socket on my V-transfer table like this. I have a plastic plate to protect my dots before scanning. And first step, I'm going to use match spray because the scan don't like shiny components. Like this. So when it's okay, I will share my screen again to show you the scan and so on. So when it's okay, we are going to begin the scan. So first step, I will scan my socket like this. So I will remove my plastic and just do it again. Okay. Like this. Okay, let's go. So I will scan the external part of my socket like this. Okay. And now I will scan inside to have everything. I will return inside. Here. Okay, a little bit here. Okay, so now it's finished. You will see the results. Okay, I will generate points. So it's loading. So what you can see, it's easy to do and it's very easy to do everywhere. And it's not necessary to have the workshop. It's now my workshop. So we are going to come back here. So the software is doing the job. So we are going to continue the presentation, and after you are going to come back. So as I told you, it's the digital transfer. After you are going to talk of the manufacturing, because it's another step. We do the transfer. Now it's necessary to manufacture everything. So I will come back on my screen here. So you can see that I have the fixed point, and I have also inside my socket so you can see that the transfer is okay. I didn't destroy my socket. So I didn't destroy my socket. Everything is okay. So it's not necessary to, the patient can keep the socket. So I can, return the socket to the patient, and he can come back home, and after I will do the manufacturing. So I will show you the next step directly in Vytruve. Okay, so here. So when the checklist is okay, I have scanned my patient, I continue, and when it's finished, I will update my file. So I update my file. I upload directly in Vytruve. I upload, and when it's finished, the scan is here, and I can order it. I will have a form to ask me what I want to do, because sometimes I want to modify a little bit alignment. I want also to remove one socks. I want to change the tramline. So here, do you want to modify? Yes. I want, for example, to modify the shape. I want to decrease by uniform, and I want to remove one sock, so it's medium socks, 3 millimeters. I can click 3 millimeters. I don't want to translate my socket. I don't want to rotate my socket. I don't want to change the height of the socket. Don't know, it's okay. I don't want to modify the tramlines of my socket. And now I can order many things. So if you have a 3D printers, you can print by yourself, and Vytruve will send to you the 3D file of the positive and installation guide. We are going to see it. Also the files of the Vytruve socket, TTTF, or also the shape inside and the origin. If you want to outsource at Vytruve production center, it's possible also to order a positive and installation guide. It's possible to order positive installation guide and tramlines. We are going to see it after, or also another TT or TF socket. And you can also ask to Vytruve many other manufacturing requests, because you can ask definitive socket, carbon fiber socket, silicone socket, what you want directly here. So you have seen the digital transfer, and now you are going to talk to the manufacturing. So what is important now to keep in mind with Vytruve, it's you can use the digital tools just for your definitive socket. So if you want to keep your plaster cast to do the patient, to cast the patient, you can also do your manufacturing check socket, and after use Vytruve for the V-transfer and also for the definitive. So you can do what you want with it. So you can go to digital with many steps, and with the V-transfer step, it's sometimes also a good choice. So now I will come back on the presentation. So I talked to you about the positive and installation guide. So what is it? When you start a digital transfer, it's necessary after to transfer these files to a real socket. For this, we have designed positive and installation guide, and this is the positive and installation guide. So you can see that it's a positive. The positive have a place for the injection tube, and you also have this. It's 4 branch. You are going to position to glue exactly the 4-hole plate directly in your socket. So with the positive and installation, you will reproduce the shape and the alignment that you have in your V-transfer. What is also good, Vytruve will reset the setting at neutral. So if you adjust the alignment with your screw, Vytruve will put everything at 0 to adapt this. So you will have other adjustment when you are going to deliver your socket. Many advantage or the installation guide at positive. It's all the digital transfer benefits, but it's also that your patient can keep the check socket, but you don't have humidity. And it's a real important thing. So you don't have humidity. So you can do silicone directly on the positive and not using an oven. And it's also lightweight. So you know this in plaster, it's very heavy, it's very lightweight, and it's also easy to remove from inside the socket. So when you do your lamination, for example, this one, I did the first lamination. So I did a first lamination directly on it. You can see that I have the injection tube. I can position this to position the 4-hole plate. And when I want to remove, I will cut here, like this. Inside is empty. I will hit inside and remove my positive. It's the same here. So with the V-transfer and the installation guide, it's not necessary to use plaster anymore, and with many advantages. So to sum up the process, so you scan with the V-transfer plate, Vytruve, or you are going to print in-house the positive and installation guide. You do your first lamination, you glue the anchor, and after you will remove the positive from inside the socket, and you will have a silicone socket or a carbon fiber socket. It's also possible to use the V-transfer plate to print a definitive socket if you have MGF printer or other definitive socket. What is also nice with V-transfer and installation guide, you can also improve your socket. I will show you, for example. Here, you can see here in the positive, you have this part. When we laminate on it, we add a space and we print a TPU, 3D printing TPU, like this to have very soft tramline everywhere. So Vytruve, you know, it's the same here. So you have the position, and after you have the socket, and you glue and you stick the TPU directly on your carbon fiber socket. So you can improve the socket for your patients. You can also print TPU with the inner socket, and it's also possible to directly use injection to manufacture silicone socket for TF with carbon fiber, because you don't have humidity, so it's very easy to do the manufacturing. You can also do upper limb definitive socket. So the price of everything. You can see on the screen that to start with digitalization, it's necessary to have the 3D scanners. So the 3D scanner is not very expensive. It's around $1,000. And you can also have the V-bag accessory to have everything in one bag. After, it's necessary to have a good computer. And you can have the V-transfer plate. So it's necessary to have the V-transfer plate. And the V-transfer plate, it's around $400. So it's for a definitive kit. If you add VTF tool to do TF socket, you will have, you know, equipment at the end of the document. You have everything to perform upper, lower limb socket. So you can do what you want with this equipment. So you can perform upper limb, lower limb, TF, TT, check and definitive socket just with this equipment. If you want to start with V-Transfer, it's just 1 hour in video conference for the first digitalization. So it's very easy to start. And after, for the manufacturing, you can use Vytruve Production Center, or you can also buy the Vytruve 3D printer. If you buy the Vytruve 3D printer, it's very nice because it's not necessary to take care of the slicing, and you are sure that your sockets are strong. You are sure that the positive and installation guide have a good quality. But also, as I told you, if you have a 3D printer, you can also have the STL file to bring by your own, but you have to manage the slicing, and a problem can happen. So you have many ways to begin with Vytruve, and many ways to begin in the digital. So to sum up a little bit, now it's really the end of the plaster from the patient to the definitive socket, with the possibility to scan the patient on stamp, to scan the patient on liner, to design a check socket. When the check socket is okay, to scan the check socket TTTF TR as you want, to print directly the definitive socket, or to laminate on an installation guide and positive to deliver to your patient a very nice socket, and your patient can keep the check socket during the definitive. And it's very a game changer. For the CPO, it's very, very nice. For technician, it's also very nice because you give to your technician the best tools. It's not heavy. It's not necessary to put in the oven. So for technician, it's also very great. And for patient, it's necessary to come back on the patient. It's very nice because you give him a very good socket, a very good process without problem, because the patient will keep the check socket. So I have a orthopedics company. I use all this process for 3 months now, and now it's really the new standard. And I'm sure in 6 months or 1 year, all patients will keep the check socket during definitive socket, and it will be the standard to use 3D printing, to use manufacturing mix with a digital, and I'm sure everything will be very, very great for patients, CPOs, and also technicians. So I'm finished with the presentation. I hope you understand the process, and you understand that it's also easy to do. So now we can take a few time to answer to the question. I'm here, so I'm totally aware to answer to the question. I can see that we have a question. So what accuracy do set on the scanners? No, it's not 0.5, it's not 0.6, it's 1.3. So you can use this accuracy to do the scan, and the accuracy will be very good. So if you have other questions, really don't hesitate. So it was okay for the process. Everybody understand the process and how it's work. So when you want the modification step, do you want when you design a check socket, or when we modify the file to design the installation guide? What do you want exactly? Okay, so it's not doing manually, it's doing by our algorithm. So when you write on the form, it's automatically doing to Vytruve, and it's our algorithm who will reduce the shape. So you can reduce the shape uniform, you can reduce the shape without touching this bone or this bone. You can also determine directly on the socket before your digitalization where you want to modify. So I can show you, because it's not doing directly on the software, it's doing by the algorithm, because it's more accurate. But Vytruve software, you can do what you want for the check socket. So for the check socket, it's Vytruve software where you can do what you want. Do you have other question? So I'm going to wait 1 minute, and if you don't have question, we are going to close the webinar. Yeah. So thank you, Arkady. So for tier, we have a specific software, so you can scan the patient, you can modify the socket, you can do the check socket, inner socket, out socket. For definitive socket, it's a little bit different, because tier sockets are very small. So if you want to digitalize check socket, it's necessary to cut the socket to scan both. But yes, it will be possible. But today, the best is to design the check socket, the out socket, and after Vytruve can design the definitive socket for each patient. So people are writing, so I am waiting. So it's a very good question, Mike. So maximum, minimum, it's really complicated to do because it depends on the shape. Just to give you, for example, this socket. This socket is very, small, but it's really not a problem. If you can see this one, this socket, it's also very small and it's working. If you see this positive at the end, it's also very small and long, but it's working. To be totally clear, it's working for 95, 90, 97% of the socket. Sometimes for 3% it won't work because it's complicated for the scan to see inside and to scan. But if you have to do 3 manual transfers per 100 socket, I think it's really not a big deal because you can do more and more. So the maximum thickness of the socket, so it's possible to do no maximum. You enter in the program how many thickness you want. So it's possible to do 3 millimeters or 10, or it depends the thickness you want and the thickness you put on the software. So it's not it's not minimum. It depends on the activity of the patient. It depends on many parameters to determine the thickness of the socket. But the CPU will decide this regarding to the parameters of the software. So thank you for this question. It's very nice to exchange, and it's also very nice to be in live because I am discovering your question, and it's nice to exchange with you. So do you have other question? Is it okay for you? Yes, it's quite the size of the chamber for printer, so it's possible to print very big socket. And when we determine when you determine your printer, when you determine a way to print, what is really important. So I will return to the printers because I think it's a good question and I want to show you something. So I will come back to the printers. So this is the Vytruve 3D printer. So what you can see that you have, so it's 8 or 10 kilogram rolls because it's important to print many sockets, many installation kits directly on these printers without changing often the walls. You have also a box behind the printers to change to avoid the humidity because it's the same for lamination, but 3D printers for the humidity is not very well. Everything is closed to avoid the humidity and to avoid when the temperature change. You can print, yes, 60 centimeter of socket, so it's big socket. It's also possibility to print a big positive. So, with these printers, you can do everything. And that's why you have chosen this, because you can print your check socket, you can print your positive and installation guide. It's not necessary to change every time the walls. And another important thing, our 3D printers is seeking for the customers, because the best is to put the walls at the top of the 3D printers, but it's complicated to put a walls at the top of the 3D printer. So it's not easy to build for Vytruve, but walls are behind the 3D printers to avoid many problems for customers. And it's at Vytruve, we are very focused on customers to have a smooth process to avoid problem. And the most important thing is slicing. So when you have the 3D printers, the Vytruve 3D printers, it's not necessary to manage the slicing. You click order and automatically the slicing will be done by Vytruve and you can start your 3D printer. So it's really plug and play to avoid problem, because the most important thing is to deliver to your patient security socket, a modified socket, and a very strong socket. So, do you have other question? Scan, software, 3D printer, patient, fitting. So we can talk of everything. So I think it's okay. Thank you very much for everyone. Thank you very much to be here. If you want information, you have all the information now in the chat. So don't hesitate to contact me or my colleague to exchange. And I hope you learn many things. And I hope you will use all the digital to do the socket for your patient, for your colleague, and so on. So thank you very much. Have a nice evening, morning, and bye-bye. Thank you very much.